Good evening, everyone, or good afternoon. We are continuing with our seminars. My name is Dr. Walter Veit, and we are going to talk about health and nutrition, which happens to be my field of research. I work at the University of the Western Cape, where we are pretty actively involved in this type of thing. I work largely with animals, food animals, and I simulate what is happening in the industry out there and try to determine what will be the effect on a consumer who consumes the animals that have gone through the raising process as it is currently done in the world out there. But this first lecture and the second one today are of a more general nature. The really hot issues come tomorrow. So don't miss tomorrow's lectures. They will be the humdingers. General things, life at its best, I've called this one. And we're just going to look at the primary nutrients in a very brief way, just to have a look how we should relate to them, what they are all about, what the world thinks about them, and what can we do to change perceptions in the minds of men. This is a very hot question today. Proteins. How much protein? You know, if you plan a dish, if you plan to prepare a meal, what is the dish that you think of? Have you ever seen anyone in the world invite someone over for potatoes and peas? Have you ever heard that? I don't think so. Very seldom. If you look at the general population of the world, it's, what are we having for dinner? Chicken. What are we having? Lamb. What are we having? Beef. Nobody says potatoes and peas and lettuce leaves and a carrot. Have you ever heard that? No. So in the minds of man, the protein is the numero uno, the number one. And the Greek for protein actually means to take first place. So for many, many eons, mankind has been schooled upon the idea that proteins are the most important component in our diet. Well, without proteins, you cannot live. Without proteins, you haven't got enzymes. Without proteins, you cannot build tissues. So proteins are incredibly important. But in the diet, do they take first place? Does that mean that the bulk of your diet should consist of protein? That is the question we really have to answer. Well, safe levels of protein intake as proposed by the FAO, the World Health Organization, and the United Nations University, three of them putting their credentials on these values, and uncorrected for nutritional value of the protein. And we'll see that in adults, we require, in a male and a female, the same amount of protein, only 0.75 grams of protein per kilogram of body weight per day. Now that is very small indeed. That means that the average woman needs between 40 and 55 grams of protein per day. And the average male between 50 and 65 grams of protein per day. You know, that is an incredibly small amount of protein. And yet, the average Westerner consumes many, many times that amount of protein. If you take a small child, you will see that even a young teenager in his growing years requires only 1 gram of protein per kilogram of body mass per day. That is very, very small amount. So if he weighs 40 kilograms, that means he needs 40 grams. And a young baby will require 1.85 grams per kilogram per day, and we'll get all of that out of the mother's milk alone. So we can see that the protein issue is really a major problem in the world today. If you are pregnant, that means you have an individual, a new life growing in you. You only add 6 grams to the total. So let's say your body mass works out that you need 50 grams of protein per day. Then it would mean that you would need 56 grams of protein per day. If you are lactating, that means demand feeding an infant in the first 6 months after birth. That means you add 17.5 grams per day. So if it's 50, that means 67.5 grams per day. Even there, 70 would be, wow, tops. And older than 6 months, it drops down to 13 grams again. Now, protein is one of those components that has to be assimilated and has to be used for whatever the body needs it for. So you need it for maintenance, you need it for enzyme formation, you need it if you are growing for growth. And you can see there that you really don't need enormous quantities. So let's take bodybuilding, for example. There was this question on bodybuilding. Do you think someone who is a bodybuilder will grow in muscles faster than a pregnant woman can extend this way? Yes or no? No. You wouldn't grow faster than a pregnant woman. So let's say your normal needs of protein are 0.75 grams per kilogram per day. What would you say would be the most that you would have to add to really be able to grow over time? Because you don't obviously pick up enormous quantities of muscle in a day. Well, do you think you need more than a lactating mother who is feeding a whole different individual who's growing like a mushroom? Do you think you need to add more than that? Probably not. But we see in the health business that people are using huge quantities of proteins. And anyway, in the normal diet, people are using much more protein than they actually require. What happens to the additional protein that we eat? When we eat protein, we digest it, and we convert it into amino acids. Is that correct? All right. Some of the protein, depending on the type of protein we are eating, can actually go through the intestines almost undigested and end up in the lower part of the intestine where bacteria will do their job. But the amino acids that we actually absorb, all those amino acids, we have to utilize them. And the body has what we call an amino acid pool from which it can draw over this 24, 18-hour period, more or less. So as long as you get all the amino acids that you require, the body can utilize these. Now, if you eat too much carbohydrate, then the body can store the additional carbohydrate as glycogen in the muscles, or if you eat too much fat, you can store it as adipose tissue, as fat. You know, the ladies can put it either up here or down there, and the men tend to carry it around here. So if you have too much carbohydrate or fat, the body has means of storing it. If you have too much protein, then what do? You cannot store it. There is no mechanism for storing protein as protein. So you actually have to convert the protein and change it into either the glycogen, which you can store in your muscles and in your liver, or into adipose tissue, into fat. And when you do that, because protein has a different structure to either fats or carbohydrates, then you have to split out the ammonia, the nitrogen in the protein, in the amino acid, because the carbohydrates and the fats that you are storing don't have nitrogen. And the body does that, and immediately, because the ammonia is highly toxic to cells, it converts it in human beings and in mammals generally to urea, which is also toxic, but less toxic than the ammonia and has to be eliminated by the kidneys. Other animals like birds and reptiles can convert it to uric acid, which is non-water soluble. They need that because they have eggs, and when they lay eggs, they can't have urea in those eggs. They need something that's non-water soluble. But we also can produce some of this, which can be a crystalline form, and if we don't have sufficient enzymes, can become a problem. So number one, if you have too much protein, you're going to have high levels of ammonia, and you're going to have high levels of urea. That brings me to the question of complete and incomplete proteins. Now you see, it's not just enough to have enough proteins, you have to have proteins that have the right amino acid sequences. And in the past, it has always said that animal products have a great amino acid mix. In fact, of all the recommended daily requirements that you have for the various amino acids, the amino acids in animal proteins supply adequate quantities of all the essential amino acids that we need. Whereas plant proteins are generally considered incomplete proteins, which means they don't have high enough levels in any one particular plant to supply all the amino acid needs that we have in terms of essential amino acids. But that, of course, only applies if you follow a restricted plant regime diet. If you have a variety of plants, you will get every amino acid that you need. So generally speaking, animal proteins are complete proteins, and plant proteins tend to be incomplete proteins. And that only refers to the essential amino acids, but not the non-essential amino acids. Let me just make one thing quite clear here. Essential amino acids are just as important as non-essential amino acids. The difference between the two is that the essential amino acids, we cannot produce them ourselves. So we cannot convert something else into those amino acids. We have to get them in the diet. So we have to get enough of all these amino acids in our diet in order to build the building blocks that we need for life. Non-essential amino acids are just as important, but it's not essential that we get them in the diet because we can convert other amino acids. We have the enzymes to produce these from other products. So essential amino acids are only essential in the sense that you have to get them in the diet because we cannot make them. And leucine, lysine, methionine, phenylalanine, that's a ring structure one, threonine, tryptophan, valine, and histidine in babies are generally considered the ones that we need. Now, if you look at the major food groups in the world, you will find that here are the essential amino acids, isoleucine, leucine, lysine, and all of those. And you look at animal proteins, you can see relatively high levels of them all. These are milligrams per gram up there. When you go to cereals, and you look at lysine, for example, and lysine is considered the limiting amino acid in the entire world. It is the one that they measure malnutrition on. You will find that animal protein will give you 84.3 milligrams per gram, whereas cereals generally only give you 30.5. So one could conjecture that cereals will not give you sufficient lysine, and therefore it would be better to consume animal products. But if you look at legumes, you will see that legumes have more than double the amount of lysine than you have in the cereals. So if you have legumes in the diet, plus you have cereals in the diet, there is no lysine shortage. And there's one other thing. If you have a diet that's high in animal protein, then that produces a relatively acid system in the digestive tract, and that hinders the absorption of lysine. So although the levels of lysine in this combination might be lower than when you had animal protein, you will actually be absorbing more lysine from this combination than you would ever get from an animal protein. So plant proteins actually can give you better lysine levels than animal proteins can give you. If we look at some comparisons, let's say seeds, which are generally complete proteins, you can see some really great comparisons here. Let's take steak, rump steak. And you look at tryptophan over there, it has 189 milligrams per 100 grams. And you look at, let's for fun, just for fun, take the pumpkin seed. 560, which one's higher? The pumpkin seed. Threonine 715-933. Isoleucine 848-1737. Leucine 1327-2437. Lysine, that's the limiting one, 1415-1411, about the same. Methionine 402-577. Phenylalanine 666, bad number. Pumpkin seed 1749. Wow, that's 3 times as much. Valine 899, 1679. Arginine 1045, staggering 4810. And let me tell you something, arginine is one of the most important amino acids. Arginine is the one that leads to your detoxification system. Arginine is the one that is used as a basis for creating urea, which is the toxic component that your body produces when it detoxifies ammonia. So it is one of those amino acids that you really need in high levels. And plant proteins generally, if you look at the list all the way through the nuts and through the seeds, give you much better arginine levels than any animal protein could ever give you. And histidine is important for little children. So on every single score, the plant protein was actually the winner. Am I right? Okay. So there's no such thing as to say that all plant proteins are incomplete proteins. Some of them are complete proteins and very good proteins. But of course, you don't live off pumpkin seeds, do you? So there is a point. You have to make sure that you have right combinations in all of this. So basically, when we ask the simple question, what is better, plant proteins or animal proteins, we cannot just look at the number of amino acids and the quantity of the amino acids that is present. We have to look at much more. We have to look at absorbability, digestibility, and the ratio of amino acids that you actually get into your system at the end of the day. Because yes, maybe there will be a large quantity of a particular amino acid, but that high quantity of that particular amino acid might be detrimental to your health. And vice versa. You might have a high quantity of a particular amino acid that you need lots of, and you don't get sufficient of it when you have one or the other. And I would like to present evidence for you today that it seems more and more probable that plant proteins are the way to go. Plant proteins are branched-chained amino acid profiles. They are much more readily digestible than animal proteins. For example, to digest a plant protein requires an acid medium in the stomach that never has to be lower than 4.5. That means you would never have to purchase an antacid. Have you ever seen an animal in the world that runs around with a bottle of antacids? As soon as you put an animal protein into your system, the pH drops because the enzyme's optimum has to be reached in order to even digest that protein. And so egg protein, for example, needs a pH of 1.5. Wow, that's pretty acid. No wonder people suffer from heartburn and indigestion. So plant proteins generally are much more readily digestible, and they give totally different amino acid profiles to animal proteins. Now, amino acids don't only contain this group called nitrogen over there that fats and carbohydrates don't have, but they also contain other components like sulfur. Like cysteine over here is a sulfur-containing amino acid, and methionine over there is a sulfur-containing amino acid. And when you break this down and you want to store energy in the form of fat or carbohydrate because you cannot store it in the form of a protein, then you have to split that sulfur out, and it always gets split out because it is a hydration reaction. It gets split out as SO4 minus, as sulfate. That's sulfuric acid. So when you have to digest these amino acids, you are producing in your system sulfuric acid. That tends to make the body go acid, and there's only one way to buffer that. The body buffers that by withdrawing calcium from the bone and putting it into the blood. Does that make sense to you? Now, unfortunately, to get rid of the sulfate, the only way you can get rid of it is by excreting it in your urine. And because it has the formula SO4 minus, in order to maintain the equilibrium, it always takes another ion with it that has a plus or a double plus. Now, because you are buffering with calcium, which is Ca++, guess which one it takes out with it? It takes the calcium out. In other words, diets that are rich in sulfur-containing amino acids are what we call calciuretic diets. You lose calcium out of the system. You urinate it out. But not only that, because of the acidity that it requires to digest them, you don't absorb as much calcium either as you would in the beginning. And then another few pointers. Some amino acids have ring structures like this one here, tryptophan and proline, which you also don't find in the fats and the carbohydrates. And these also have to be split out, and they're split out as phenols and threonines and things like that, which are basically carcinogenic in some cases, or tend to be harmful products that have to be eliminated in the urine. Or they accumulate in the colon, where bacteria also break down some of these proteins and can cause problems over there. So a high-protein diet has a number of serious hazards. Let me just summarize this for you. Plant proteins contain more branched-chain amino acids than do animal proteins. And they are easier to digest than animal proteins. Everybody understand why? If you're branched chain, then the enzyme, the pepsin that digests it, can cut it up more readily because it can get in. It doesn't have to have the high acidity to unwind the proteins. Then animal proteins are rich in sulfur-containing amino acids, cysteine and methionine, and have a greater proportion of aromatic amino acids, phenylalanine and tyrosine, so they create more of these ring structures. And excesses of these two groups of amino acids have been associated with very, very degenerative diseases. Let me give you another important component. Plant proteins produce higher levels of arginine. Could you see the pumpkin seed was more than 4 times as much as the animal protein? You remember that? And all those in between had much higher levels of arginine than the others. Plant proteins also give higher levels of glycine in the blood than do animal proteins, and the higher levels of these two amino acids are associated with protection against the clogging of arteries and arteriosclerosis. That comes from various scientific groups, Nutrition Report International, you name it. This comes only from the scientific literature, from peer-reviewed journals. So plant proteins give you an amino acid mix which protects against disease. Another important factor is the ratio of certain amino acids, like lysine, remember that was the limiting one, and arginine, where you get lots of in the plant protein. That could be an important factor in determining the ability of a protein to induce arteriosclerosis. And that comes from review of clinical studies on cholesterol lowering response, Journal of the American Dietetic Association. So we have lots of evidence today that we cannot say a protein is a protein is a protein. When I started out doing research on proteins, and I have a lot of graduate students working on nothing other than protein, protein, and protein, I would not receive funding from the government agents because they said they don't understand what I'm doing. They say a protein is a protein is a protein. You digest it and you have amino acids and that's it. Then I write back to them and I say, no, that's not it. When you digest the plant protein, you get this profile. When you digest an animal protein, you get another profile. And that protein profile is good, and this protein profile is bad. Then they write back and say, it makes no sense to us, no funding. So then we started our research ourselves, and I used departmental funding to do it. As the professor, you can do those things. Just did it. Just used the funding and got the students through. And wow, then there was great excitement. But it took a lot of excitement before they finally started funding this research. And today, I'm a very highly funded scientist, and they love it. They love it, and they love the controversy, and they're just giving me money. I even get money from the Royal Society London for this research, which is very strange for a South African. Phenols have been implicated as promoters of bowel cancer. Ammonia increases cell proliferation, also has been linked to colon cancer. This comes from Bingham, 1996, Epidemiology and Mechanics Relating to Diet to the Risk of Colorectal Cancer, Nutrition Research Review, Volume 9, page 197. So there's a lot of information coming out. The Dunn Nutrition Center in the UK also does a lot of research on this, and it really is great to see that more and more we are beginning to realize that you can't just say a protein is a protein is a protein. So to summarize it for you really simply, I would say arginine and glycine need to be high in your diet, and you'll get that from a combination of plant proteins. You will never get it from animal proteins unless you eat a lot of animal proteins, which has another problem. And there should be enough lysine, which is the limiting one. But if you have combination, grain, legume, you should never have a problem. In Africa, sometimes when the nations get very poor, they only have maize, just one grain, and they have a gruel of maize every day, and that's their diet. That's a very poor diet because it has very low levels of lysine, and then maize in itself is one that is very highly water retentive, so they tend to suffer from malnutrition. But African nations that have grain-legume combination are the healthiest people on the planet. All right, so we did some experiments just to see if this was so. And what we did, we fed equivalent amounts of protein, exactly the same amount. So we gave these animals, rabbits in this case, an 18% protein ration. So they got everything else that a rabbit gets, you know, carrots, chomp, 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 apples, lettuce, leaves, you name it, everything a rabbit likes. But the protein source in the pellet was derived from soya protein versus milk solids as a protein source. And then the same amount of protein in both groups, and then we determined what was the level of arginine. And how do we want arginine? Do you remember? High. And we fed these animals, and lo and behold, you can see that as time progressed, the group that received soya immediately was a lot better off than the group that received the milk solids. And it stayed that way. There was a little compensation on the milk over time, but arginine levels were always higher, significantly higher than in the other group. Plasma arginine levels of rabbits, and now we compared soya and casein. So we didn't take milk solids now. Maybe the fat has an influence on absorption. So we just took the straight protein, the protein isolate from soya. We didn't take the milk solids. We just took the protein casein, which is the protein in milk, And we compared that, and what do you see? Soya gave high arginine profiles, and casein, which is supposedly one of those supersonic, high-profile proteins, complete proteins, gave a much lower profile. Glycine, remember what glycine had to be? High. So we looked at glycine. And here we again have soya and milk solids. And look at that. Glycine was just about 3 times as high as you would get it with milk as a protein source. And the same happened with the other. And here are a lot of publications which tell us that rabbits that are fed animal protein develop arteriosclerosis and have elevated cholesterol levels even if their diet is cholesterol-free. Wow. If they are fed plant proteins such as soya, these effects are not observed, and the plant protein source was shown to decrease the degree of sclerosis even in those animals that were fed cholesterol. Now, that's not from me, that's from the literature. So we were interested in this. Why is it that animals that were not receiving cholesterol at all, no fat in the diet that contained cholesterol, why is it that if you give them one type of protein, cholesterol levels rise, and if you give them another type of proteins, they don't do that? Why does one group get arteriosclerosis and the other one doesn't? You see, the type of amino acid that you have in the end determines which proteins are going to be built. And cholesterol is carried in the blood by 2 groups of protein. The one is a high-density protein, the other one is a low-density protein. And we call it LDL and HDL. HDL is high-density lipoprotein, and the other one is called low-density lipoprotein. It's a smaller molecule and tends to go into the blood vessels, whereas the other one tends to stay outside in the blood. And so if there is cholesterol around, that protein will grab it and put it into the blood and take it out of the vessels where it causes the damage itself. So the type of protein determines whether you have good or bad cholesterol, and not really the quantity of cholesterol that you eat. Protein becomes far more important in terms of your overall health, and the control of protein levels is far more important than we ever realize. Animal proteins increase cholesterol levels. That is the bottom line. The protein alone increases the cholesterol levels, whereas plant proteins tend to reduce the levels of cholesterol in animals and humans. Do you know that just feeding someone who has high cholesterol levels beans, simple beans, baked beans, is probably one of the best ways of reducing cholesterol levels? And that is one of the amazing things that we're coming around to finding out. It is therefore not surprising that various national bodies and expert groups recommend an increase in the consumption of plant foods to improve long-term health. And then you can check it out in the literature. It comes from American Journal of Clinical Nutrition and many, many other sources. There are lots and lots of references. So we looked at rabbits, and we had a look at the cholesterol levels of the rabbits that were fed 18% protein, and we compared soya and milk solids. Remember that the milk solids have a fat component, am I right? And true, cholesterol levels, overall cholesterol levels, were much lower in the group receiving the soya than in the group receiving the milk solids. Now the question arises, is this increase in cholesterol as a result of the cholesterol that we find in the milk solids, or is it as a result of the protein? How do you test that? Well, you take away the milk solid and you just take the protein. You just take the casein minus the cholesterol. And what do we find? The same ratio. Can you see that? So what is it that elevated the cholesterol level? Was it the cholesterol and the fat in the milk, or was it the type of protein? It was the type of protein. And when we start understanding this, we can see that the type of protein that we consume can have a great impact on our cardiovascular system. Now, let's just talk about this issue, proteins and calcium. This was one of the great issues where we wanted to do research, which costs a lot of money. It's one thing about research, it costs a fortune. We're talking thousands and thousands and thousands of rands just to run one project of this nature. We were very interested in the protein-calcium connection. Remember the theory that I told you? If you feed something an animal protein, then it would have higher sulfur-containing amino acid levels. It would have to split that sulfur out as sulfate, and that would result in a loss of calcium. Firstly, to buffer, and secondly, when you excrete the sulfate. Am I right? Okay. By the way, pets, when you feed them animal protein, and you feed them the food, the cat food, and the this and the that, it has a very high level of animal protein in it, because the world is geared to the notion, well, that's a carnivore, therefore it needs a lot of meat. And therefore they give it high animal protein, and their kidneys pack up. So most cats die from kidney failure. In nature, the animal also eats animal protein, but it is an opportunist. It eats then, and then sometimes for a few days not, and then eats again. But a pet gets fed protein levels at a level that it never ever really requires, and that is why our pets are diseased and dying of kidney failure. And even the veterinary associations of the world are saying, don't feed your cats milk, and don't feed them so much of this protein-rich food. They're beginning to understand, but they still don't know exactly why. Proteins and calcium. If you double your protein intake, you will cause a 50% rise in calcium excretion. 142 grams of protein per day will put anybody into negative calcium balance, whether that is plant protein or animal protein. And soy protein maintains calcium much better than any animal protein. So let's have a look over here at the incidence of hip fractures in women as opposed to per capita protein consumption in the world, milligrams per day. You will see that the nations that have a low protein diet don't have hip fractures. And those that have a high protein diet, United States, New Zealand. New Zealand is the biggest meat-eating country in the world, paralleled only by United States and white South Africans. And they're all up here and have the highest incidence of hip fracture. How much calcium supplementation does the United States take? Till it comes out of their ears. And they have lifted up the daily recommendations for calcium to 800 international units. I mean, really very high compared to what the rest of the world is taking, milligrams. Dietary protein increases the production of acid, as we said, which can be neutralized by calcium mobilization from the skeleton. So it's not just me saying this, comes from the American Journal of Clinical Nutrition, 1995, volume 61. And we decided we want to check this thing out. So osteoporosis is caused by a number of things, one of the most important things being too much dietary protein. American Journal of Clinical Nutrition, Journal of Nutrition, the journal Science, everybody has this basic understanding of the issue. And in spite of it, they still won't fund you when you tell them you want to really check out why. Incredible. Well, so let's just go through this. You increase your protein consumption. You will increase your calcium loss because of the buffering process. That'll put you into negative calcium balance. That can affect your bone mass, and that can lead to fractures or deformities. Am I right? That's the theory. Now, in the industry, in the animal husbandry industry, animals are fed incredibly high protein rations. One of the reasons for this is when you feed an animal high protein rations, you are forcing it to convert that protein into fat or carbohydrate, and you are forcing it to store it, so it leads to fairly rapid growth. And so the industry feeds very high levels of protein. Now, when you feed, let's say, sheep, high levels of animal protein, because sheep get fed in the industry today, not grasses and shrubs like in the old days, it takes too long for them to grow. They get fed fish meal, carcass meal, blood meal, all those components. Carcass meal is everything that has been rejected at the abattoir as diseased. It is ground up, dried, pelleted together with grains and other things and fed back to the animals. It's one of the reasons why we have mad cow's disease, because you perpetuate disease that way. But you know what? In many, many countries, they will even have trucks going around picking up animals that have been run over on the road, dead rotten dogs and dead rotten cats and this and that and the other, and all of that goes into carcass meal. So it makes for a nice palatable morsel for whoever has to consume it. Well, there was a problem in the industry with sheep that were getting skew leg syndrome. Their legs were buckling. Now, that doesn't really matter if you're going to slaughter the sheep and eat him in the form of a chop, because nobody's going to see that a chop was skew in the beginning. But when you have a stud ram that costs thousands and thousands of bucks, well, if he comes out looking like a cowboy, that's a major problem in terms of the amount of money that he will raise. Does that make sense? So the industry was very concerned, and I was giving a lecture and I claimed that the reason why they are getting skew legs is because you are feeding them too much protein, and particularly animal protein. Of course, they didn't believe me, but one of the scientists in the agricultural group came to me afterwards and said, are you really convinced that what you are saying is right? And I said, yeah, I'm convinced. He said, well, can we do an experiment on this? Can we run a graduate student through a program? I said, sure, I've got one, right ready, let's move. So we did it, but he didn't want to test plant protein versus animal protein. He just wanted to test high protein versus low protein. And I nagged and nagged and nagged until we got it that we even tested plant protein versus animal protein. They couldn't understand my reasoning. You know, it didn't make any sense to them. Protein is a protein. So I explained and explained and explained, but eventually they knuckled under. So we took 50 mutton merino grams, about 100 days old, 12 days old and weighing 100 plus minus 12 days. So they were just over 3 months. They were just weaned and weighing about 28 kilograms. So they were still nice and small. And we divided them into 5 groups. And the first group got a 12% protein diet, basic diet, all derived from plant protein. And that's exactly what a sheep would get if we just grazed outside in the field. Does that make sense to you? Okay, so that's basically what he would get if he could get a little bit of lucerne to boost his diet and basic plant diet. Then we did what the industry did. We took the basic diet and we added 3% animal protein. So a 15% protein ration, of which 3% was animal protein. And we took the same basic diet and added 5%, that brought it to 17%. And then we took the same basic diet and we added 8% animal protein, and that brought it to 20%. Now, if you think, because we've been criticized over this experiment like you cannot believe, because the animals look pretty ghastly when we're finished with this thing. But the industry goes up to 35%. Okay? So we were being very nice to these animals. And by the way, I believe in animal rights, and I believe it's not right to confine animals to cages and to torture them and to do whatever we like with them. But in this particular case, what I do is all I ask them is whether I can climb on their bus and ride with them a little while, feeding them, their animals, what they would feed them anyway. And then taking some of them and feeding them something that I think is better. Do you understand what I'm doing? So I don't think I am initiating something that is against animal rights. Indeed, I am working towards proving to them that what they are doing is unethical. So it's actually favoring animal rights. So I get to be quite controversial on this issue. And then to have this double test, we took the same basic 12% protein diet, all plant, and we added also 8% plant protein in the form of grain gluten. We added that, and so we had a 20% total protein, all plant-based. You all understand what we did? Okay. At the end of this period of 6 months growth, so the animals were then 9 months old, that's what they should be when they are market size. The 12% plant-based diet had, this is limb skewness, had very nice straight legs. Then skewness in some increased when you added 3%. It increased more when you added 5%, and it really shot up when you added 8% animal protein. The plant protein one, 8% added, is not here. We'll compare it just now. So that is just starting with 12% plant and adding animal protein. Up goes the skewness. Now let's have a look at what that looks like. Now there's a Mr. Legs. Perfect. Straight legs, nice profile. He would do well on the plank. And there the legs start getting a little bit deformed. And this particular one was the 8% added plant animal protein. You can see that the foot structure here is very distorted. The leg is incredibly bent. This particular animal could not walk by itself. My colleague over here is lifting it up. And when it did walk, it walked on the calcaneus, which is down here. It looks like it's elbow, but it's not really, because of course they have an extended finger. So really, it is disastrous. In the field, the animal probably would not have gone that bad, but in a shed situation where it doesn't get exercise, which is what the industry does, that is what happened to the animal. So once it's shorn, you can see tremendous deformities in the legs. And we had, of course, 10 per group, and most of them, this one was the worst one, but most of them in the animal group tended to be like this. One other thing, just for interest's sake. The group that received the plant protein, and these were all rams, when you went in to work with them, they allowed you to work with them. You know, you draw blood and you take urine samples. How do you do that? Well, you tie a little bag down and you say, please do it. That's what you do. Normally, they do it anyway because they're nervous and afraid, so you don't have a problem with a urine sample. The fecal sample is a problem, because you can't pick up the fecal sample from the floor because they could have urinated on it and then you'll have a contamination. So you have to put on a glove and say, excuse me, Mr. Ram, do you mind if I take a sample from the source? And you take it out the back there, and that's what you analyze, you see. Now the problem is that when we climbed into the group that had a basic plant diet, that was okay. We could quite readily work with it with two. They would look at you like this and feel kind of like a sheep, a bit dumb, just standing there allowing it to happen. The more animal protein they had received, guess what? The more aggressive they were. When you climbed into that 20% plant protein group where of 8% was animal protein, I'll tell you, you had to be very, very careful, particularly as a male, or you come out of there singing soprano. They used to lower their horns. They used to go from, we had to climb in and hold on to them for dear life. What we wanted to see, what do we see in the x-rays? There is no osteopenic bone. There's no sign of anything really strange going on, but the legs were skew. So they were weak, right? There is the group in comparison, samples of what we determined as very skew, straight, and intermediary. And then we had a look at something very interesting. We analyzed the bone of these animals because obviously they were in this industry, so they were going to be used for the industry, and I'm afraid they did end up as chops on somebody's table in the end after all. But we did have samples to analyze. We analyzed the bone calcium to phosphorus ratio and found something very fascinating. As you increase the animal protein, so the ratio calcium to phosphorus in the bone